On rotations, on the video icon project, I'm going to collect this on Wednesday before the quiz. So those of you that did not get this finished over the weekend, did not get through the reading piece, you can still go through and finish that up. Rotation of 90 degrees about the origin. I always get confused about rotations.
She's saying don't talk.
Okay. We're recording this about the origin. Does anybody know what the origin is? Where is the origin on a coordinate graph?
And in the middle.
Isn't it where the X and Y meet?
It is where the X and the Y meet. So what is that point?
0.
It is 0, 0. Okay. So the only piece that we're going to be looking at with rotations is around 0, 0. There are so many rotation points, but this is the only example we're going to really work with and make sure we understand. Now, it does tell us right here what it is we're going to do. Let's see how many of us understand what it says. A rotation of 90 degrees about the origin. So we're going to go 90 degrees in this direction. Can be seen in the picture below, in which A is rotated to its image A prime. So A is going to A prime. And then it tells me, and I love this, the general rule for a rotation by 90 degrees about the origin is this. AB is going to go to negative BA. Now, some of you are like, it's like you're speaking Chinese to me. I didn't understand that. Let's go ahead and put some numbers in there. Sometimes when our brain sees numbers, it makes it a little bit easier to understand. Let's put in 2, 1 is going to go to negative 1, 2. Could someone say in their own words, summarize, what just happened to the points? How am I going to remember this? Wyatt.
Switch letters and the first number becomes negative.
Okay.
Switch the numbers.
Okay. So we're going to switch. Now, did you notice they used A and B? Usually we use what two letters to describe a coordinate point? No, what do we normally use to just? We normally use X and Y. So basically, Wyatt was saying, we're going to switch the X and Y. Oh, see, now I got into the middle of my switch the X and Y. Switch, I'm going to put in here places for the X and Y. So the X and Y just basically switch places. And then he said something else happened. What else happened there? We switched the places. The 2 went back here. The 1 went up front. Oh, and then the 1 became a negative, which is actually the Y. The Y becomes the opposite. Now, I'm not going to say the Y becomes negative, because what if the Y was negative to begin with? What would it become then?
Positive.
It would become positive. Let's just pretend, let's just pick another point here. Negative 3, negative 5. And let's use Wyatt's rule here. He's like, switch the places for the X and the Y. So they basically just switch. So negative 5 goes here, negative 3 goes here. Okay, I've got that. I can always switch these places. Now what happens?
The 5 goes into a positive.
The 5, which was the Y, who's now over here, he's negative, but now he becomes a positive. So when I go to work on my video icon project, whichever image I want to rotate, all I'm going to have to do is switch the places for the X and the Y, and then the Y always becomes the opposite. Switch the places for the X and the Y becomes the opposite. Switch the places for the X and the Y becomes the opposite. And pretty soon it's just so routine. It's always nice to put it in your own words so that you know that little mantra. What am I going to repeat to myself over and over again? And then pretty soon you have it. Moses, did you have a question?
Where do we get 3 and 5 from?
I just picked out a point.
Okay.
That's the other thing when I read through math, I'm kind of always testing myself. Do I understand what it's saying? So then I can just pick out a point, and although 3 and 5 isn't a really good one because I really can't see what's going on here. Let's do 1 and negative 1. 1 and negative 1, which means we're going to switch them.
And they'll both be positive.
And then that first one now becomes a positive. So it's going to rotate. Really? 1, negative 1. I switch them. Oh. Yeah. He's going to rotate 90 degrees. He went from here to here. Does that make sense?
Will you slide your paper a little bit, please?
Yeah, that makes sense. Here's my origin. Here's where he was. If I rotate it 90 degrees, look. Did it land right there? Perfect. Yeah, it works. So you can always make up another point just to test it to make sure that it's going to work. Real quick, let's see how good you are with 180 degree rotation. A rotation of 180 degrees about the origin, so we're going to go from here to here, can be seen in the picture, but here's the general rule. AB is going to switch to negative A, negative B. Who can say, hey, this is really what you're doing?
I can. You're making the A and B, both of them are going to be opposite.
Both of them are going to be, do I switch them, do I switch places?
No.
Nope. So X and Y, I'm always switching back to X and Y because that's really what a coordinate plane is. X and Y stay in the same place, but both become the opposite. And if you want to just check it out, you can look at that example. We had 2, 1, and when it rotated 180 degrees, it's at negative 2, negative 1. They stayed in the exact same place, but they both became negative. So for your video icon project, I really don't have any preference which rotation you want to use. If you want to do a 90-degree rotation, you would follow this rule. If you wanted to do a 180-degree rotation, if your shape lent itself really well to that, do this. X and Y stay in the same place and both become the opposite. And now, since we've done both of these, I bet you can read through the 270-degree rotation and figure out what it is you're supposed to do. Because usually once you figure out 1 or 2, all of a sudden then it's like, okay, now I know what I'm looking for. What's going to be the difference between the points? Okay, that was one of the things that was mentioned. Let's go ahead and look at our study guide now. And I'm going to be asking, oh, this is the one we use. I'm going to be asking for some people to help present some of the questions. Let's go ahead and look at number 7. Ooh, this is a good one. I'm going to start with this one. I remember this from this one was a question asked last hour, and it's a good one.
Where's 7 at?
Yeah,
Oh,
the picture.
7's right here. It's number 8 that you really can't find because number 8 decided to leave the page. I don't know where number 8 really went, but okay. If triangle 3, so I refer to my picture, here's triangle 3, is reflected over a line so that the image of A, well, here's A, is at negative 4, negative 1. Okay, comma. Does everyone understand what's going on here? Oh, good. If you don't, just reread it again. Triangle 3 is reflected. Okay, so in my brain, I'm picturing a reflection. It's over a line. I don't know which way it's reflecting, but it does tell me that the image of A, which is right here, is at negative 4, negative 1. Can I plot negative 4, negative 1 pretty quickly?
Yeah.
Yeah. Let's go ahead and get him down. Here's -4. I'm going to walk over to the elevator, and then I'm going to go down 1. Okay, so here's the image of A. Okay. So he's going to reflect over to here. So A has to go over to here. What is the equation for the reflection line? Now, what do we know about the reflection line? Who can tell me, just by looking at what we have right here, what do we know about the reflection line?
That it crosses over the y-axis.
Is the reflection line going to be a vertical or is it going to be a horizontal line to get over here? So it's going to... So if you think about a line, it's reflecting, it's going over that line. So a horizontal line will give... It has to go across it, so it's going to have to be a vertical line, right? Okay, so we know that it's going to be a vertical line. Now let's look at our options. I see that I have 2 that are x equals and 2 that are y equals. Okay, so that basically tells me I can cross off 2. Which 2 are not vertical lines? What are my 2 questions when I have to ask myself so that I know which way it goes? Which axis does it cross? And where does it cross at? Now, I remember that you have these 2 questions twice in your notes. Okay? So, this is good to put this down here because if you still don't get this, go back to your notes to see what was it that we were talking about. Okay. If we know we're talking about a vertical line, it looks like this. Which axis does it have to cross?
The y. Oh, the x.
It has to cross the x-axis. So which 2 can I cross off then?
All the y's.
I can cross off the y's. Okay, you just made the problem that much simpler for you. Just because you're thinking through what is going on, you know that you have the vertical line. Now we only have to deal with, is it x equals 1 or is it x equals -1?
X equals -1.
Why are you not saying x equals 1?
X equals -1.
Here's x equals 1. Would that make sense that it reflected over there?
No. No.
Why does it make more sense for it to reflect over x equals -1?
It doesn't.
Who can justify why that would have to be the correct answer?
Then I thought of it a different way.
Because you're going left.
When you reflect over a line, did you notice that A was 3 units away from the reflection line?
Mm-hmm.
How far away is A prime?
3 units.
That's exactly what has to hold true. If your pre-image is such a distance away from the reflection line, your image has to be the exact same distance. So we know that my answer has to be x equals -1. This is a great one to go over your notes. It's in there twice, okay? You have it in your notes, and there was the flow chart that also went over this. If it's horizontal, vertical lines, that's going to be your purpose of going over your notes. What's the difference between horizontal and vertical lines? When you have a study guide, it's not just about being able to solve the problem. It's being able to understand what is all of that behind it. Why are these answers not correct? Why is this answer correct? Okay, the next one is 10A. Well, let's go ahead and answer 10. The figure to the right is an example of what type of transformation? What's going on here? How do you know it's a rotation?
Because
Right.
it changed from standing
Wait,
up.
what?
It changed from standing up. I like is where?
The 1 minus
3. Well, when I use a corner point, and you know what Gage just said is probably the #1 quiz taking strategy. Let the quiz help you.
Oh, yeah.
A lot of times, answers for questions are right on the exact same quiz. Because look at what 10 asked. What kind of transformation? 10A is obviously connected to 10, and it says the point of rotation. Did it give you the answer?
Yeah.
Yeah, it gave you the answer for 10. So, and sometimes it's on a different page. Sometimes you're going through a question, you're like, wait a minute, I think I saw something like that. Go back to that page. It may be giving you an answer to something down the road. That happens all the time. Okay, number 17. This one came up a bunch. A bunch.
It did.
I wonder why that one came up a bunch.
I don't know.
I'm
I
taking
got
it all out of all of your cards here so that we don't hit it again. Okay, well, let's read it. Let's see what's going on here. An image is congruent. Okay, if we don't understand congruent, we don't understand the question. What does congruent mean?
Ain't it the same?
Okay, the exact same.
Well, good job.
Okay, so we're looking for something that's the exact same to its preimage if it follows which rule? Okay, I think what I'm going to do is I'm going to have you tell me what's going on with each rule here. And then we can figure out which one's congruent.
Okay.
In A, 2x minus 3, 2y minus 3. This is a sequence. We got more than one thing going on here.
Dilation and translation.
Oh, it's a dilation. How do you know it's a dilation?
It's a dilation.
Oh, because of the x minus 3.
No, how do we know it's a dilation?
No, that's a translation.
How do we,
It's a dilation.
is it getting bigger or smaller?
It's getting smaller. It's also moving.
Ah, it's a dilation and it's moving. So we've got the two things. We know it's a dilation. We know it's a translation. How do you know it's a dilation? What in there?
The 2x and the 2y.
Ah, it's the 2. That tells me it's a dilation. What does that tell me about the dilation?
It's moving.
Getting 2 times bigger.
It's 2 times bigger. What did the minus 3 and the minus 3 tell me?
Translation.
Translation. Which way is it moving?
Left and down.
It is moving left 3 units and down 3 units. I'm using shorthand here just to kind of make sure. Hey, is this an option? Is it going to be the exact same size?
No.
Is it congruent?
No.
No. Why is it not congruent?
Because it's a dilation.
Because it's a dilation. Okay. Because I went through and I analyzed option A, I can already cross it off. It's a dilation. It's 2 times bigger. It's not congruent. Tell me about B.
It would be
Oh, that's
X
a-
would get off.
Hang on, that's supposed to be a Y. I tell you what, when I type 4x and 4y, what's happening here?
It's getting bigger.
And how many times
No,
bigger?
four
It's more.
times. 4.
It is 4 times bigger.
It's moving.
No, it's a dilation.
Could it be wrong then?
How do we know it's a dilation? How do we know it's a dilation?
I didn't do very good then.
Because you know it's a dilation because 4.
Ah,
Because they're the-
because I'm multiplying by 4. Chad, how do I know when I'm moving it?
Because there's
It's when
either
it's in front.
it's a letter and then there's a minus
when it's
plus
behind.
minus or plus sign.
If I am adding or subtracting something, that tells me we're sliding it up or down. Or left or right. Okay, so is B even in the running for the answer?
No.
No, it's bigger. It's not the exact same size. Well, what's happening here with C? We've got 7x and y.
X is getting bigger.
X is getting 7 times bigger.
And Y is staying the same.
So, y staying the same. Is it congruent?
No.
No. In fact, this one's not even proportional.
The same as D.
So, C is not even an
It's
option.
D because you're not getting bigger. You're just moving it.
And which way am I translating it?
You're going right and then down 8.
I'm going right 5
And down 8.
and down 8. There was nothing in front of my X or my Y that would make it bigger or smaller. The only thing I was doing was sliding it back and forth. Okay, awesome. Okay, I need a volunteer
Me,
Hi,
I volunteer.
to present.
I'm a volunteer.
Let's look at it first.
Never mind.
The sequence of transformations from ABC, the big guy,
ABC.
to A prime, B prime, C prime, the little guy.
ABC.
Who either would like to present, and you can say, hey, I haven't solved this, I'm trying this for the first
I
time,
haven't solved it.
I'm
or
sorry.
maybe you have solved it and you would like to present your solution.
I'll give it a try. I didn't
Okay.
figure out the- Okay, aren't we gonna rotate it?
Do you want to come up here and present it?
Can I talk from here?
You were going to talk from there. Okay, we're going to rotate it. Where are we going to rotate it from?
Oh. Well,
Or which direction? Or what's happening
To the
here?
right? Like go this way?
Where are you going to rotate from? Maybe we need a point.
I don't know, but do we rotate?
Do you think we have to rotate?
No, we
When you
will
turn it
eventually.
over-
We will eventually.
Yeah, I know we gotta rotate at some point.
Well, let's rotate. I'm good with rotating it first.
The B, rotate the B.
Rotate from the B.
Oh.
Okay. And how many degrees are you going to rotate it?
Wouldn't that be 90?
90. In which direction?
To the left?
To the left, like this way?
No.
What happened?
You're going to go this way.
Wait, what?
Are you going to go this way?
Yeah, sure, go that way.
That would be counterclockwise. CC. Okay. Oh, good. I do have a pencil here. Let's see. It's going to look like this.
Yeah.
Yes.
Okay. Now, I would strongly suggest if you're trying to find a sequence of transformations that you actually draw them out as you go so you can see what's going on. Okay, so we just rotated it 90 degrees counterclockwise. Here it is.
Translate it now.
Okay? Translate. Which way am I going to translate?
Woo! Right?
I'm going to translate
No, 2 units to the
right
right. 2 units.
2 units. Okay?
And 1 unit down.
Oh, and then translate
1 unit down.
down
Mhm.
1 unit.
And then
Okay.
you gotta dilate it.
Okay, let me just, so now we're going to be, oh, we're actually like right on top. There we go, there it is.
Now we have to dilate it.
Oh, we got to get it smaller, so I'm going to have to dilate it. Do you guys know exactly how much I'm going to have to dilate this?
1, 2, 3.
It looks like this side length was 4, and now it's 2. And it looks like this side length
So,
is 6.
0.5. Dilate it 0.5.
Ah, 0.5. So dilate by a half. And then it'll land right on there. Perfect. Totally different sequence than second hour. So when there's a question like this, and there will be, because sequences of transformations is something you definitely need to know how to do, I will go through each and every one of your sequences to make sure that it will get to where it needs to go. There's so many sequences we can use. Now, this right here is a great example of what to do. You have used the words, and you have given me very detailed what it is we're doing. But we have already moved farther than this. If I'm going to rotate 90 degrees counterclockwise, do we know how to do that?
Yeah.
With coordinate notation? We do. I have to think back to what Wyatt said. We have to switch the points, and the first one becomes a negative. So there's coordinate notation for rotate this thing 90 degrees counterclockwise. What would coordinate notation look like for translate right 2 units and down 1 unit? What would that look like?
Let's see.
coordinate notation, what would it look like?
2.
What, the 2, if I'm going right,
no,
does
no,
that
no,
affect the x
no,
or the y?
X plus 2. And then y minus 1.
Okay. This right here, putting it into coordinate notation, would put you into the expert category. Because not only do you know what the sequence is, you actually know the coordinate notation of what would have to happen. Ooh, how do I dilate by a half? How does that look like with coordinate notation?
You can go 1/2 or you can go 0.5.
I could do either. Awesome.
Cool beans.
Yep, you just took your sequence. Here, let me show you what second hour did. Second hour, they dilated it first. So they made this big guy small. They dilated it by half, which is exactly what you did. Then they translated it 4 units up, so they went up to here. Then they rotated it 90 degrees, just like you did, negative yx. And then they just translated it 8 units over to the
ours
right.
was shorter.
Who's writing it?
This one took 4 steps. Yours took technically 3. You had 4, but you used your translations together so we could put them all in one deal. Okay? Questions on this? Rotations are going to be extra credit on the quiz. So if you are really wanting to get some extra credit points, there are some of you and some 8th graders that score above 100% on quizzes. You rock the quiz and then you also get the extra credit. 105 and 108% definitely help
Why is
with
it
the grade.
rotations?
We just weren't able to spend as much time on rotations. So if you put forth the extra effort and work on rotations at home, I will give you the extra effort and put it in your quiz. Okay. Definitely know your sequences. Know how to get from one to the other. Remember that square that we did? You can easily practice by going through a set of sequences and then getting back to the first one. You can make up all sorts of problems to help you practice that. Okay. Let's see. How are we doing on time? I can't see.
You got 8 minutes.
8 minutes. Awesome. I have a question on 14. Let's jump to 14. Another coordinate notation. Okay, so we got to understand what's going on. Which transformation rule shows a translation 2 units to the right and 2 units up? Go ahead and answer that in your own paper just to see how much you know. Can you actually pick out the right answer? 2 units to the right and 2 units up. Do you know enough about coordinate notation that you can understand which one is saying that exact rule?
Yep, me found it all.
We're good?
Oh,
Okay, go ahead and raise your hand if you chose A.
I think I did.
Okay, raise your hand if you chose B. Raise your hand if you chose C. And D. Okay, so nobody thinks C and D is correct. We're going to come back to those. We had some A's and some B's. You know what? A and B has 2's all over the place. Can someone tell me about B? What is B actually having us do?
Dilation.
How do you know it's a dilation?
It's getting bigger.
How do you know it's getting bigger?
Because there's no
The numbers are in front of the letters.
Because we are multiplying by 2. So B is actually a dilation 2 times bigger. Okay, well that's not what we want. Now, why do you think A is the correct answer?
Because it's
We're just doing the right
plus
thing.
and y plus.
It's adding it, and when I add, it's going to move the x to the right, and it's going to move the y up. A is
D
correct.
is another dilation, and so is D.
Wait. Is D a dilation?
Yes.
No.
Yeah.
It looks to me like the X is going to get 2 times bigger and the Y is going to get
3.
3.
Skinny
How's that
man.
picture going to look?
It's gonna look like they have the tallest head in the world.
So it's not going to be proportional. Is that a dilation then?
Yes. No.
No, it is not. If it is not proportional, it is not a dilation. What's happening to C?
Smaller, which is a dilation.
It is a dilation, and this one's getting smaller. It's half the size. Okay. Let me go through. I know 15 was asked as far as a question, and so is 16. They're all on coordinate notation. We've done some similar to that. Let me see if there's some other questions, and we can come back to those if we still have time. The next one was on number 5.
Number 5.
Okay, this is some hands-on stuff. We've got the graph. This one's a little different. Quadrilateral ABCD is reflected over the x-axis. If I were taking the quiz, I would probably highlight the x-axis so I don't accidentally reflect it over the y-axis. Okay, what is the new ordered pair for B prime? That's my question. You already know?
I did it.
Hey, what was the rule for reflecting?
You gotta reflect over the
If I'm reflecting
Opposite.
over the
tan.
x, the x stays the same.
In the Y.
And the y changes. Do we have an actual answer here?
Yeah, I do.
I don't know, do we?
Yeah. I do. You don't have to count.
I don't think the answer's on there.
No, you have to write the answer to those. That's just the
Oh,
Oh,
coordinates of
these
that.
are the coordinate points for that.
Yeah.
Whew! Thank you for helping me read that. These are the coordinate points for this baby. Oh, so since I know the rule for reflecting, I don't even really, that's not even where it's going to be, is it? Oh yeah, that's where it's going to be. The x stays the same, but the y changes. So is it 4, -4?
Yep.
And then I could go ahead and check myself on here just to make sure. Yes, there it is. Perfect. So those rules that we learned based on here are actually helping us with the quiz. They give us another tool that we can use. Okay, we've got that one. Let's see. I think we hit this person's card. Oh, no. We have to do number 11. Triangle ABC. Oh, A prime, B prime, C prime is the image of quadrilateral. Oh,
I had no idea.
that would be a typo.
Yeah.
Is the image
No, I
of triangle ABC under a dilation of O. Now, how do I know how big the dilation's going to be? How do you go about count? I heard count. What are you counting? You know what? This is an easy one to count. 1, 2, 3. That little guy has a side length of 3. So now I have to find this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has a side length of 3. This has a side length of 9. So it has to be a dilation of 3. 3 times 3. There you go. Okay, we got that person's questions answered. How are we doing on time? We are almost there. We have hit almost. What is the rule for hey, we can do this. We just did this one. We need to hit 18 yet. What is the rule for rotating 180 degrees?
Negative.
I'm going to go back and look.
180 degrees.
They stayed in the same place and they both became the opposite. So it would have to be
B.
They stay in the same place and they're both the opposite. It would have to
18.
be B.
It'd be A. No, wait, yeah, it would be.
The questions that talk about coordinate notation for transformations back here that have just a lot of questions to make you think. Down here with the rotations, those will be extra credit. I will have those marked on the quiz. So for those of you that understand rotations, this is a chance to get some extra points to help your grade. For those of you that are like, I want the extra credit, I would go through and read our reading on rotations to make sure you know what's going on there. Okay, you guys are going to have your quiz tomorrow. I would strongly suggest for the 98% of you that did not get this done, I would suggest you still work on this tonight. Just because you're not going to get the extra credit for the study guide, still use it to move your thinking.